In this video, we're going to factor a fourth degree polynomial function. So given the function x to the fourth plus 7x cubed plus 11x squared minus 7x minus 12, our directions are to find all zeros and factor as the product of linear factors. So you might remember those two things are closely related, right? If you have a linear factor, you have a zero. If x plus 5 is a factor, the zero is negative 5, right? When we say 0, x-intercepts, same thing, if they're real zeros. All right, so that's what we're trying to find here. So remember how to do that. These are not easy problems to factor. In fact, we have to factor them by doing long division. All right, so overall the directions are to find all the zeros and to factor. First, we'll start with listing all the possible rational zeros. So remember, in order to do that, we want to look at all the factors of this number, the last term, the constant term, divided by the leading coefficient, which in this case is 1. All right, so that's all your factors of 12 plus or minus 1 plus or minus 12 plus or minus 3 plus or minus 4 plus or minus 6 plus or minus 2. That's a lot of factors, right? And normally we would divide all of these by this number, but because it's 1, it's not going to change anything. All right? So in a lot of these problems, you're given some hints sometimes, like maybe you're given 1, 0 to start, or maybe you have a picture of the graph so you know a good place to start. In this case, we're not given any of that, all right? So this will be more complicated, one of the more complicated problems where we have to really start from scratch, okay? So what do I mean when I say start with scratch? Well, I need to decide if these zeros, these possible rational zeros, right, which are 1, 2, 3, 4, 5, 6 of them times 2, since we have to do plus or minus, that's 12 possible zeros, are in fact actual zeros. So how do we do that? Well, we do synthetic division, right? 1, 7, 11, negative 7, negative 12. Synthetic division or long division. Synthetic division is a lot quicker though. All right, remember, if one of those possible rational zeros is in fact a 0, then that means you get a remainder of 0 when you divide, right? It'll go in evenly. So what do? You just pick one of them, all right? So for example, I would pick, how about negative 6? Why negative 6? No reason, right? You're just going to have to check all of them until you get one that works. You can start with the smallest, go to the largest, however you want to do it. I'm just going to pick randomly negative 6 and do my synthetic division. 5, and that's going to be negative 30. And I can see pretty quickly that this guy is not going to work, because when I multiply negative 6 and negative 37, whatever that is, it's not positive 12. So it's going to give a remainder, which means he's no good. All right. How about try another one? How about positive 3? That was one on my list of rational zeros. All right, see if I get remainder 0, 9, add 16, 48, add 59, multiply that. That's 150 plus 27, which is 177. I think I can stop there because that's definitely not going to be 12 to give me a remainder 0. So no good. We're 0 for 2. All right, so I'm going to try smaller value here, see what I get. This is the process. You just test all of those rational zeros until you get a remainder 0, and then you have a factor. So let's see. 1, 7, 11, negative 7, negative 12. 1, 1, 8, 8, 19, 19. Add those guys together. I think I get 12. I got lucky. All right, so with the third case, I have found 1, 0, which means I have found a linear factor. Remember, if x equals 1 is a 0, which is what we just determined, x equals 1 is a 0. Okay, that means that x minus 1 is a factor. But not only that, when I divide, by x minus 1, I get a quotient, right? This is a third degree polynomial. These are the coefficients. That's the cubed term, that's the squared term, that's the linear term, and so on. X cubed plus 8x squared plus 19x plus 12 is the same thing as the function I started with. So think about that for a second. This, what I'm calling f of x, is the same as this f of x up here, right? I can't call them both f of x if they're not the same. So what I've done is I've just divided by x minus 1 and got a cubic. Okay, so now the question is, what do I do next? Well, I still don't have a nice way. Remember, we have nice methods for factoring quadratics, but not for cubics, right? Not for quadratics. So we still got to do long division. Now, what I'm going to do is long division on this guy, because if it's a 0, it's got to go into this. So I got x cubed plus 8x squared plus 19x plus 12. 1, 8, 19, and 12. My cube term, my squared term, my x term, linear term, same function. Okay, so back to your list of rational zeros. We've tried 3. There's still several more. So I'm going to try, I got lucky with 1. I'm going to try negative 1. 1, 8, 19, 12. See what happens. 1, negative 1, 7, negative 7. 12 multiplied by negative 12, and we got another one. Okay, so this is good. This means negative 1 divided into this piece. Notice I didn't take it into the 4th degree. I took it into the result of my first successful division, so this 3rd degree polynomial. So that means just this guy factors as, if that's a 0, x plus 1 is a factor, and this is the result. Right? This is my squared term. This is my linear term, and so forth. Okay, so that's just this cubic factored as the product of the linear and the quadratic, and this guy we got from before. So now I have f as this. Right? I have as a linear, and a quadratic. If you multiplied all that out, you should get this. All right. So now we're factoring. We found 2 zeros. Right? The zeros are x equals 1 and x equals negative 1. We got those by trial and error, long division. If x equals 1 is a 0, then that's a factor, x minus 1. If x negative 1 is a factor, then if x equals negative 1 is a 0, then that's a factor. Okay, so now what do we do? Now we're stuck with this guy. How do we deal with that? We got to find the zeros from him, but the good news is we've got it down to a quadratic. Once we're at quadratic level, we have a couple ways to find zeros. We can factor it. If it doesn't factor, we can use the quadratic formula. Okay, so first thing I'm going to do is try and factor. This will factor as long as I can find two numbers that multiply together to give me 12 and add together to give me 7, which I can do. So that's good. So we did 2 steps of long division, or synthetic division rather, to find my first 2 zeros, which correspond with these 2 linear factors. And now I can find the final 2 factors by factoring like we've always done with quadratics. Okay, so this one turns out factors as the product of 4 linear factors. I didn't need to use the quadratic formula, so let me make a note of that right here. Right, I just want to highlight that guy, because once you get it down to quadratic, a few things can happen. It can be nice like this example here, and it could factor as the product of 2 linear factors, which we got. If it doesn't, you could use the quadratic formula to find the zeros, and then remember what the quadratic formula will give you: irrational zeros, either real or they could give you complex zeros, right? If the discriminant is negative, you'll get complex zeros there, right? So the point is, once you get it down to quadratic, you got methods that don't require long division, right? And for this case, we now have all factors, and we could also, the problem originally also asked us to list the zeros. So this guy right here in the first box is the function written as the product of linear factors, and down here I'll just list the zeros: 1, -1, -3, and -4.